Okay, the most common unit for describing the composition of solutions, that is describing how much of a particular solute is present in a given solution, we usually like to use molarity. And molarity is simply defined as the number of moles of a solute for every 1 liter of solution. Okay? And this is the most useful solution composition unit because it gives us a direct relationship to how many molecules or ions of our solute are present in a given volume of solution, and it allows us to very easily determine the number of moles so that we can, for example, measure out the appropriate mole-to-mole ratios for different chemical reactions. Okay, so let's take, for example, the compound sucrose is a sugar. It's your basic table sugar. It has a molar mass of 342.3 grams per mole. That is, 1 mole of sucrose weighs 342.3. So if we have a sugar solution and its concentration is 2 molar, that is 2 moles of sucrose for every liter of solution, we'd say, and if we have 1 liter of that solution, that means that we have 2 moles of sugar. Or if we have 2 liters, we therefore have 4 moles. If we have a half a liter, we have 1 mole of solution, of sugar in that solution. Okay, or a total of 342.3 grams of sucrose in that half liter, or 684 in a liter of that solution, in terms of grams. So it directly relates the moles of solute to the liters of solution. And so when we calculate molarity, we are going to simply determine the number of moles of our solute, and we are going to divide that by the volume of our solution in liters. Okay, so let's take a couple of quick examples here. So again, it's the moles over liters. So if we take 4.75 grams of sodium chloride and we dissolve it in water and make a final volume of that solution to be 750 milliliters, we can calculate the molarity first by calculating the number of moles. Okay, so we have 4.75 grams of sodium chloride. To convert that to moles, we use the molar mass. So 1 mole of sodium chloride weighs 58.5 grams. And so we will take 4.75 divided by 58.5. Tells us that we have 0.0812 moles of sodium chloride. Our volume here is given in milliliters, but we need to convert this into liters simply by dividing by 1,000. In this case, which is just going to be moving our decimal place 3 positions to the left. So we have 0.750 liters of solution. So in calculating the molarity, we take the moles, 0.0812, divided by 0.75 liters, telling us that the molarity of this solution is 0.108 molar. And this capital M again represents molarity, or moles per liter. So for every 1 liter of sodium chloride, we have 0.108 moles. If we have 2 liters, we have 0.216 moles, etc. Now, because this is an ionic compound, we know that for every 1 mole of sodium chloride, we have 1 mole of sodium ions and 1 mole of chloride ions. It's often also useful for us to express the concentration of each of the ions in solution. And to do this, in this case, it's relatively straightforward because the moles of each of the ions is the same as the moles of our compound. So we would say that the concentration of sodium ions in this solution also equals 0.108 molar, and the concentration of chloride ions will equal 0.108 molar because of this 1-to-1 ratio. So let's do one more example. Okay, so if I want to make a solution of magnesium chloride, and I take 55 grams of magnesium chloride and I dissolve it in a volume of 275 liters. Okay, not milliliters. And I would like to know what is the molarity of this magnesium chloride solution, and what is the concentration of each of the ions. And so I'm going to first convert from grams to moles. So I take 55.0 grams of magnesium chloride I want to convert that to moles by saying that 1 mole of MgCl2 weighs 95.21 grams, right? That's just adding up the atomic masses to get the molar mass of magnesium chloride. So that will give the number of moles, and then I'm going to divide that by the volume in liters, which in this case is 275 liters. So I plug those numbers into my calculator, 55 divided by 95.21, and then divide that whole thing by 275, and I find that the concentration of magnesium chloride is equal to 0.00210 molar. That is, for every 1 liter, I have 0.0210 moles of magnesium chloride. So that is the concentration of the magnesium chloride. In every 1 mole of magnesium chloride, I have 1 mole of magnesium and 2 moles of chloride. So we would say now for our ions, if I want to express just the magnesium ion concentration, represented by these square brackets, I would see that it would be the same, because there's 1 mole of magnesium for every 1 mole of magnesium chloride. So this is 0.00210 molar. Another way to say that is it's 2.10 millimolar. And the concentration of chloride, though, because we have 2 moles of chloride for every 1 mole of magnesium chloride, the chloride concentration is going to be twice that. Right? For every 1 mole of magnesium chloride, we get 2 moles of chloride. So it's going to be 0.00420 molar chloride, or 4.2 millimolar magnesium chloride.